Is graphing a cosine graph. There are a couple things to take into account. Today our cosine equation is y equals negative cosine 2x minus 1. So the way that this is different from the original equation, which is y equals a cosine bx plus c plus d, is it's compressed horizontally by 2, and it's reflected over the x-axis, and it's shifted down by 1. And the reason I have this a, b, and c here, they're kind of markers, but we have an a, we have a b, but we don't have a b, and we do have a d. So the amplitude in a cosine graph is given by the absolute value of a. And so a in our graph is 1. So we have our amplitude is 1. The period in a cosine graph is found by taking 2 pi and putting it over the absolute value of b. And in our equation, b, which is here, is 2. So we have 2 pi over this absolute value of 2, which simplifies into pi. And our phase shift, which means it goes either left or right, so it affects the x values, is negative c over the absolute value of b. And so c in here is, we don't have one. So that means we don't have a phase shift. When graphing a cosine equation, we are given a couple understood points, and those points are going to change based on the changes we made over here. They're going to affect our x and y values. And so to graph these, we start off with 0, negative 2, which is all the way down here. We go pi over 4, negative 1, right here. Pi 2, pi over 2, 0, there. 3 pi over 4, negative 1, right here. And pi, negative 2. Now this is one period, and we'll keep extending it this way. So as you can see, 0 to pi is one period, and our period over here, like we said before, is pi. So to make it 2 periods, we just repeat the pattern. So 5 pi over 4 will be up at negative 1, then 3 pi over 2 will be at 0, and 7 pi over 4 will be back down to negative 1, and 2 pi will be at negative 2 down here. And this is going to look like this. It's going to go up, come all the way back down, that, and like that.
The equation is a cotangent, which is the inverse of tangent. And the equation is y equals 2 cotangent parentheses x over 2 parentheses. So first we find how it deviates from the original equation, cotangent x. So we know it expands horizontally because it's 1/2 of x, 1/2 is the b, and then it expands vertically because the a up here is 2. So, and then the amplitude, there is none because the range is all real numbers, so there's no minimum and there can't be a maximum, so there is no amplitude. This is the period. We find that with the equation pi over absolute value of b. And we know b is 1/2, so we do pi over 1/2, and then multiply the reciprocal, and you get 2 pi as the period. And then d phase shift, there is no phase shift because there is no c, and the equation for phase shift is negative c over absolute value of b, so there is none. The first vertical asymptote is at 0, so we already have a line there. And then our first point is pi over 2, 2, so that's right there. And then pi 0, right here. And then 3 pi over 2, negative 2. And then our vertical asymptote for the other side is 2 pi. So this is what the graph looks like of 2 periods of our equation. And the graph is curved like this because that is just the way cotangents This is our cosecant equation, y equals negative 1/2 cosecant, parentheses, x plus pi. So first we find how that deviates from the original equation, y equals cosecant x. So it is reflected over the x-axis because there's a negative right here. It is vertically compressed because of the 1/2 here, and it moves to the left pi. And there's no amplitude because the domain is all real numbers, so there is no minimum or maximum, so there can't be an amplitude. The period, the equation is 2 pi over absolute value of b, and as b is 1, that makes the period 2 pi. And the phase shift, the equation is negative c over absolute value of b, so that would be negative pi over 1. So it's negative pi. Okay, these are our original points for the cosecant equation, and we're changing them to match the changes in the cosecant equation. So we are subtracting pi from the x values and multiplying the y values by negative 1/2. So negative pi becomes negative 2 pi, negative pi over 2 becomes negative 3 pi over 2, negative 1 becomes 1/2, x equals 0 is negative pi, pi over 2 is negative pi over 2, 1 is negative 1/2, and x equals pi becomes x equals 0. And then Kyle has already graphed this out, but we can see that these are the asymptotes in the x's, and then these are the maximums and the minimums for our cosecant equation. And we can see that it has shifted this way, negative pi, and it has been vertically compressed.